Hi everyone, welcome to the another problem solving session from circular motion. In this problem, we say that a boy whirls a stone in a circular track of radius 1.5 meter at a height 2 meter above the level ground. The string is break and the stone is fly off horizontally and strike the ground after traveling a horizontal distance of 10 meter. Now we have to neglect the air resistance for the following calculation. First, we have to find out what is the magnitude of the centripetal acceleration of the stone during the circular motion. And second one, we have to also find out what is the time period of that stone during this circular motion. Okay, fine, let's start. So this is the case if we are considering over here, say if the stone is rotating about a 2 meter from the ground, and say it's rotating about that direction. So this is the direction of rotation. That circular track is rotating, so the radius of this circle is 1.5 meter, which is that radius is given. And once at that point, when the stone is at that point, that string is break and that stone is fly off toward that direction and it's travel a horizontal distance which is that given, which is actually that 10 meter, right? This is I draw actually the top view of this scenario, which is at that point the string is breakdown, and after the breakdown this is the side view, that particle will or the stone will travel in that horizontal direction. So now if we want to find out, and I also label, say this is my y-axis over here. Now if we want to find out that first question, which is actually the centripetal acceleration, to find out that we know that the magnitude of the centripetal acceleration, basically the formula is A is v square over r, right? So this is actually the formula to find out the magnitude of the centripetal acceleration, where r is the radius that's given, which is 1.5 meter. Now v is the speed. We have to find out that is speed when it was just fly off. To find out that velocity, basically we can find out, because it's travel a horizontal distance, I know that distance, so we can use that formula. X would be v naught x t, horizontal direction, that would be basically v into t. So that's when if I know that time period, because after that fly off the particle will move under the influence of only the gravitational force, so that means it's a free fall. It's a two-dimensional case actually. Then if I could find out the time of flight of the stone, I know the distance of horizontal distance, then I'll be able to find out that v. If I could find out the v, then I'll be able to find out that centripetal acceleration, since I know that radius, which is 1.5 meter. Fine. How I'm going to find out that t over there? So that's t, time of flight. We can use time of flight using that equation. Y would be y naught plus v naught yt plus half of ay t square, right? So this is be my formula. Now this y naught is going to be the 0. This v naught t is also going to be the 0, because when it is fly off, it has only that horizontal velocity. It has no vertical component of the velocity. Fine. So in that case, this equation become, I can write this y would be equal to half of y naught, half of ay t square. Then this y actually will be minus 2 equal to minus half of 9.8 into t square, right? G is minus 9.8. Then I can find out the t from there. So t would be basically is going to be that this minus sign will be cancelled out from there. So I will find out 4 divided by 9.8 square root. That will give me the time, or the flight of time of this stone is 0.4 seconds. Fine. So if I know that flight of time, I'll be able to find out that V, now x equal to Vt. So then in that case, that V would be x by t. X is 10 and t is 0.64. Then I will find out that V would be 15.63. 15.63 meter per second. So this is actually the speed of that stone. So that magnitude of that centripetal acceleration, which would be A would be V square over R. There's V is 15.63 square divided by R is 1.5. If you plug in, then you will find out that centripetal acceleration of this system would be 162.76 meter per second square. So this is would be the magnitude of the centripetal acceleration of the stone before the string is break. So this is that answer number A. Now for the answer for the B, calculate the time period of the stone during this circular motion. So the time period we can find out that the t, because we know that the velocity in the circular track would be distance divided by t, right? The distance would be basically the twice pi r, right? Because if this is a circle, it has a radius r, then the total distance or the circumference of this circular track would be basically the twice pi r divided by t. Now we can find out that t from that time period, which is actually twice pi r divided by v. So 2.3.14 and the r is 1.5 divided by 15.63. Now it's give that t is would be 0.60 seconds. So this will be actually the time period of this stone before it stone the break. So that's we need to make the one revolution, it will take that 0.6 seconds. This is the answer of the question number B. Okay, thank you very much.